Today we learn how to plot linear functions using the y-intercept and rise over run. Linear functions create straight lines when graphed. We can see that on our right-hand side. Our green graph, which is a linear function, is a straight line. The general equation of linear functions is y equals mx plus c. X is our independent variable. It is our input. Y is our dependent variable. It is our output. M is our slope. And c is our y-intercept. In our graph on the right-hand side, we have this equation y equals 2x minus 3. Let's consider the slope and the y-intercept. In our equation, we know that the slope is 2 because it is the coefficient of x. We also know that our y-intercept is negative 3. Now we can use these two values to plot the linear function. So what I could do first is plot a point at negative 3, my y-intercept. I could then find a second point by using rise over run, the slope value. We've already said our slope value is 2. If we make 2 a fraction, we can express that as 2 over 1. Using rise over run, that would mean we rise 2 units up and we run 1 unit to the right. Rise from our y-intercept 2 units up, and we would run 1 unit across to the right. We would then have a second point over here. Once we have 2 points, we would simply connect the 2 points with a straight line, and boom, we have our plotted linear function. Using the y-intercept and rise over run, plot both linear functions on the coordinate plane. Our first function, y equals x plus 2, we can see that our y-intercept is positive 2, so we can write c equals 2. Next, we consider slope. What is the number in front of x? Now, we don't see a number there. However, there is an invisible 1, and that is our slope value. Now, we need to convert that slope value into fraction form so that we can find the rise over the run. 1 can be written as positive 1 over positive 1. Our rise is 1 and our run is also positive 1. Let's plot some points. Our y-intercept was 2, the purple dot there. From that point, our rise was 1. We go 1 block up. And our run was positive 1. We go 1 to the right. And again, we plot another purple point. We have 2 points. We can now connect those with a straight line. And we have our function y equals x plus 2. Our second function, our y-intercept is negative 3. So we can write c equals negative 3. For our slope, again, we look at the number in front of x. Now we can't see it, but there is an invisible 1 in front of the x. And that makes our slope value equal to a negative 1. Again, we need to convert to fraction form. Negative 1 can be expressed as negative 1 over positive 1. Plot these points. Start with our y-intercept of negative 3. Our rise was actually a fall. It was negative 1. So we go down 1. Run was positive 1. We go to the right by 1. Plot a new purple point. And now we connect the 2 points with a straight line. And there's our function y equals negative x minus 3. Progress check. Have a go yourself, then check your answers with mine. Our first function, y equals x minus 3. Our y-intercept is negative 3, so we write c equals negative 3. Our slope is the number in front of x. There's an invisible 1, so m equals 1. We convert that to fraction form. We plot our y-intercept, negative 3. Rise was positive 1. We go up 1. The run was positive 1, across 1. And we plot our second point. We connect those 2 points with a straight line. Our second function, y-intercept is positive 4. So we can write c equals 4. Our slope, the number in front of x is negative 2. We write m equals negative 2. Express it as a fraction. So we start with a point on our y-axis. The y-intercept is positive 4. We put a point over there at 4. The rise was negative 2, which means we go down 2. Run was positive 1. We go across 1. We draw a new point. We connect the two purple points with a straight line. Our last function, y-intercept is negative 2. Slope is the number in front of x, which is a half. And we express that as rise over run. We plot our points, y-intercept of negative 2 over here. Our rise was positive 1, so we go up 1. Our run was positive 2, we go to the right 2 places. We put a purple point over here. We have our 2 points. I'm just going to use a purple line so that you can see this one. A purple line is the function y equals a half x minus 2. And that is how we plot linear functions using the y-intercept and rise over run. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.